Good morning.
Good morning.
How are you doing?
Doing good. So far, so good.
That's good. All right, so we're gonna start chapter 4 today. Do you have any questions before we start? Any question? If not, we're gonna go ahead and start chapter 4. Okay. So chapter 4 is about a polynomial and a rational function. All right, so we're gonna finish these two sections today. Okay, and tomorrow we're gonna finish the three other sections. So what is the important thing about this chapter? Well, this chapter basically is the graphing. All right, so we need to learn how to graph the polynomial. Of course, you can still use the calculator to do the graphing, but you also need to know a little bit characteristic of the polynomial that way. So it is, if you look at the graph, right, we say you can use the calculator, but when you look at the calculator graph, can you still answer the question? So that is one thing. So that's why we still have to learn quite a bit of the concept for this chapter. Okay, one thing is the most important thing determine the graph is called a leading term. Okay, so what is the leading term? It's the highest degree of the polynomial. Okay, so what is a polynomial? Polynomial are gonna have a x like a x cube plus 2x squared, plus 1. This is a polynomial, right? If I let f of x equal to this one right here. So this is a polynomial. And since this one highest term is 3, so this is called a leading term, okay? That is the leading term, which is the highest degree term in here. And since this one, the highest degree is 3, so we call this one is a cubic. Okay, we call this is a cubic function in here. All right, and if I have y just equal to x squared, what do we do? What do we call this one here? Well, since my highest power is only 2, so we call this one is a quadratic, right? That's all we learn in chapter 3. So that is a quadratic equation. So this one is called a leading term. And the first item, or the highest degree term, is the most important one, because this term determines how the graph is gonna look like, right? If I have this one right here, my graph is gonna look like a parabola, okay? So that's the quadratic. And if I have a cubic here, this is gonna look at something like that, okay? So that is a cubic one. And how about if I have a y only equal to x? Well, we know this will be a linear, will be just a straight line, right? So that is called a leading term. The highest degree term will determine how the graph is gonna look like in here, okay? So, and then we want to learn how to factor the polynomial, finding the zeros. So that is this one in here. Okay, so how does the polynomial look like in general? Well, in general, we have a sub n x to the n power. So this is called polynomial. One thing, polynomial, n is always integer. This power is always integer, okay? So that is the power. Look at it. The power, the coefficient is all real number, okay? A sub n, these coefficient are all real number. So we already learned some of the polynomial. Look at it. When f of the x equal to 4, that means we have a x to the 0 power, right? X to the 0 power is equal to 1. So you have a 4 times 1 will be equal to 4. So when you have a constant number, you can kind of think this is a degree of 0, okay? And this will be, well, how does y equal to 4 mean? That's how y equal to 4 look like, right? It's a horizontal line in here, okay? And when the degree of the x is equal to 1, look at that, we don't write down 1 for a lot of things, but that's 3x to the 1 power, right? So that's the highest degree is 1. And this is a linear, right? This one will be a linear in here. So we call this is a linear, okay? And when the highest degree is, let me make this a little bit bigger. All right. on the highest degree, look at this one right here. This highest degree is 2. Okay, this highest degree is 2 in here, and we call this is a quadratic. Okay, and this one highest degree is 3, right? And we call this is a cubic function. Okay, we also have a highest degree as 4. We call this is a quartic, not a quadratic. Quadratic is 2, degree of the 2. Okay, quartic is degree of the 4. So now we are determine how the graph look like. Okay. Of course, as I said earlier, you can always put this one in a calculator, but we also have to learn a little bit for that. Okay. So when some people say, how about if you have a degree of the 5? Oh, we do not have a specific name for the degree of the 5. We're gonna just call the degree of the 5, degree of the 6, and so on, right? But from 0 to 4, we have a specific name for them, okay? So for the 0 or the constant number, we call this is a constant function, right? It's just y is stay the same all the time. This is y equal to 4 or f of x equal to 4, okay? And for the degree of the 1, this is a straight line in here, right? 3x plus 1, you have a y-intercept as 1. So this is not quite straight, but this is a straight line. Should be a straight line in here. Okay, straight line in here. So that is called a linear. And degree of the 2, we also have a name 3, 4. Okay, so that is the specific name for this one in here. Now we look at this quadratic equation. This is the one we learned all in chapter 3, right? So we're gonna using the same concept for the other polynomial. This is a quadratic, right? If I factor this one right here, I factor the -3, right? So how do I factor -3? I will factor, since my middle term is also negative numbers, so I'm gonna let my big number as negative and then 1 as positive, right? So if I -3 times 1, I add up together, I got -2, which is exactly the middle term. All right, this is factoring, right? If I factor into 3 and -1, I add up together will be +2. All right, so my middle one is -2, so we're gonna this one. We're gonna put this one right here. So that's how you factor into x minus 3 and then times x plus 1. So that's how you do the factoring in here. Okay. All right. So since we have this factoring, that means we have a zeros as -1 and 3. If you make y equal to 0, right? And x plus 1 should be 0, okay? And then solve for x, x will be -1. If you make this factor into 0, you solve for x, x will be 3. Okay, so now we have this called zeros. So what does zeros mean? That means x value will make a y to be 0. Okay, so that's the x value. So x value equal to -1 or 3, y will be 0. So that's called the zeros point. Okay, and the zeros point is since y is 0, so that's the x-intercept in here. Look at that. This is the x-intercept. This is x-intercept. -1 and 0, 3 and 0. That is the x-intercept. Okay. Can we also find out the y-intercept? Yes, y-intercept, the concept we have earlier is when x equal to 0, find the y, right? That's y-intercept. So we're going to have of the 0 in here. So what is the f of 0? Oh, that means everything with the x term will be 0. That will be 0. And then that will be 0, right? Anything with 0 term will be 0. So what's depth? I only have a -3 depth. Only the last term, -3 depth. So my y-intercept here will be 0 and -3. Okay, so that's the concept in here. X-intercept is you make a y equal to 0, you find the x. You find the x, right? So that's the intercept. Y-intercept, you make a x equal to 0, okay, and then find the y. All right, so that's the concept for the intercept in here. So the intercept for the linear and the polynomial and the quadratic and the cubic, or even the quartic, they are all the same. Okay, the concept is all the same. You just solve a different equation here. Right. And we also know this is gonna be facing up because my coefficient of the x squared is 1. Okay, my a is 1 right here. Okay, my coefficient a is 1 is greater than 0. So greater than 0, this parabola gonna be facing up. Okay, or you can even put in a calculator to graph that. So since this is facing up, we're gonna have a minimum. Okay, this is facing up, so I'm going to the infinity, and going up and up. So we're gonna have a minimum in here. So how do I find this minimum? Well, we know find the minimum is on the vertex. Okay, so that is on the vertex in here. So how do we find the vertex? Well, we talked about earlier. You can complete a square, or you can using the formula. Okay, so what is the vertex formula? Well, the vertex formula is negative b over 2a. Okay, and then f of the negative b over 2a. Oh, this will be negative in here. All right, so that's the vertex formula in here. So how do I find x equal to 1? Well, I look at this one right here. My a is 1, right? My b here is negative 2. Okay, so my vertex is negative b over 2a. I can put this one in here really quick. My vertex x is negative b over 2a. So negative b is negative 2, a is 1. Okay, and negative become positive. 2 over 2 is 1. So that's how I got a vertex x equal to 1 in here. Okay, and how much is the y value for the vertex? Well, y value for the vertex will be f of 1. Look at that. My negative b over 2a is 1, right? So I just plug 1 into the equation in here. So when x equal to 1, 1 square is 1, 1 times 2 is still 2, so this 1 minus 2 minus 3, right? And that's how I got a negative 4 in here. That's how we get a negative 4 for the vertex. So that's why we have a vertex here is 1 and negative 4. So if you look at this one right here, it's very quick and easy to find a vertex using the vertex formula. Okay, all right. So that is the vertex in here, and we have a vertex is the minimum, right? So y minimum is y minimum, okay, is equal to negative 4. Okay, the minimum is equal to negative 4 and x equal to 1. So what's the maximum? Well, maximum is infinity, right? So or you call none in here, okay? Because this keep going up. So we have a minimum is infinity, okay? It said don't have a minimum because this is open one, okay? And what's the domain and range? Okay, we're gonna talk a domain and range concept again in here. As I mentioned earlier, domain and range are gonna be in every chapter, which is true, okay? So what does domain mean? Well, domain is all the x value, okay? So what kind of x value we can have? Well, since the quadratic equation, there's no x in the denominator, no x in the square root, right? So these don't have any limitation. So domain will be all real number. For the quadratic, actually it's for the linear, actually it's for any polynomial, okay? Any polynomial domain will be always all real number. And what is the range? Range is the y value, okay? So what is the y value in here? Well, if you look at this one, we have a y minimum, okay? We have a minimum for the y in here. My minimum y is negative 4, right? And this keep going up and up. So my minimum is from negative 4 to infinity. Of course, the graph will pass the vertex in here, so we have to include a negative 4. We have to include the minimum in here. Okay, so that is the quadratic equation for this one right here. So we kind of pretty much just go over the chapter 3. Okay, any questions? All right, so now we're gonna look at the cubic function in here, okay? So look at this one right here is a cubic function. And we're gonna still find the same thing we have earlier. So one thing is you will probably wonder, how do I factor this cubic function? Okay, we're gonna learn factor this cubic function later on in the chapter, which is tomorrow. Okay, but for now, this one is already factor for you. So after factor for you, how do you find the zero? You make y equal to 0, right? So each factor gonna be 0, and you solve for x. So x plus 4 equal to 0, right? Solve for x. X will be -4. So you have a -4, -1, and 3. So you have a 3 zeros in here. So that means we're going to have a 3 intercepts, 3 x-intercept. Because 0, that means the x value make a y to be 0. So you're going to have a 3 x-intercept here. So we have a -4 and 0, and then this one is -1 and 0, 3 and 0. Right? So we have a 3 x-intercept in here. How do you find the y-intercept? As we said earlier, find the y-intercept is x equal to 0, find the y value. So we're going to have a g of 0, okay? So g of the 0, x is 0, this will be 0, this will be 0, this will be 0. So what's that? Only the last term there without the x. So we have a y-intercept here will be -12. So x is 0, so we have a 0 and -12 in here. Okay, so that's the y-intercept in here. There's one called a relative minimum and a relative maximum, because the reason it called a relative is in a local. Okay, so the local one right here, this is called a relative maximum. Okay, relative maximum in here. This one is called a relative minimum. Okay, the reason it's called relative because it's only compared to the left and the right, not compared to the entire graph. So the relative minimum or maximum, sometimes you also call the local minimum and local maximum in here. Okay, only compared to your left hand side and right hand side on the tallest one. So that is this one right here. Because what is the real minimum and maximum? Well, this cubic function can go all the way to infinity. And then this one is go all the way to negative infinity. So there's no maximum or minimum here, basically. Okay. All right, so but that's called a relative because it is in the local in here. So domain, we talked about earlier, domain for the polynomial. Cubic is part of polynomial, right? There's no x in the denominator, there's no x in the root. So the domain for this one will be all real number, okay? And what is the range, which is y value? Domain is x value, right? Range for this one, since this is gonna going up and up, this is going down and down. So the domain for the cubic is also all real number. Okay. Any questions so far? All right, so we're gonna recognize some of the function is called a polynomial. Some of the function is not polynomial. Okay, this is an example of the polynomial. So we said earlier, this is a quadratic, right? This is a constant, and then this is how the cubic look like, and then this is the quartic, which is higher degree as 4, and this is -1. So the coefficient is negative, so that's facing down. Okay, so that's the example of the polynomial. This one is the example of what? Non-polynomial. The reason this one is not a polynomial because this has a absolute value. Okay, and when we have absolute value, the graph we're gonna have a very sharp corner in here. All right, have a very sharp corner. So this is not a polynomial. This one is not a polynomial in here either because you have a square root. So my x power is not an integer, right? You have a square root is kind of the power of 1/2 in here, power of 1/2. Okay, and this domain is not all real number because we said the domain for the polynomial should be all real number. What is the domain in here? Well, this x is under the root. So x plus 1 must be greater than or equal to 0. So x must be greater than or equal to -1. That is my domain here. That is my domain. Okay. So this domain here is not all real numbers. So you can see this one is non-polynomial. All right. This one is also non-polynomial. Why this one is non-polynomial? Because I have a fraction on the power. Okay, my x power is not an integer. So when it's not an integer, you have also have a very sharp corner in here. Okay, any questions? All right, how about this one right here? Well, this one is called rational function. This actually is called a rational function, which we're gonna learn in the later of the chapter. Okay, so it's not a rational function, it's not a polynomial. Okay, because I have an x in the denominator, right? So what is the domain for this one right here? Well, this domain I have an x in the denominator. Denominator cannot be 0. So that means the x cannot be equal to 1 of this. Okay, so this is called non-polynomial in here. All right. So next time when you see x in the denominator, x in the square root, x in the absolute value, x of the power is not integer. This is all what? Non-polynomial. So polynomial actually is a very pure function in here. So what is a polynomial? Polynomial, if you look at the graph, it should be a continuous and smooth. Okay, so what does continuous and smooth mean? That means you basically can graph using one, without stopping. Graph the whole polynomial. You can graph like this one or that one, whatever. Graph the whole thing without stopping, and it's also smooth. Okay. All right. This page is probably the most important page for this chapter. Very, very important page for this chapter. Why is that? This one tell you a little bit characteristic of the polynomial. Look at that. Okay. So if you have a polynomial as an even power, the leading term, okay, that's called a leading term in here. So if you have this one, what is the even power? Even power like a x to the 2 power, x to the 4 power, right? So this is quadratic, this is quartic. They are all even power. So even power, you're gonna look at either facing up or facing down. Depends on the coefficient. Okay. If I have this coefficient A is positive, this is gonna be facing up in here. If I have this coefficient gonna be negative, this is gonna be look like that, gonna be facing down. Okay. Some people say well, quartic and quadratic look the same. Not quite. Quadratic is always symmetric. Quadratic is always symmetric. Quartic, on the other hand, not always symmetric. Okay, so that is the difference. But this power, when they all even power, they look similar. So they look, we call this is a head and tail, right? If you think this is the fourth one is the head, and the last one is the tail in here. So we can see the head and tail facing the same direction. Look at that, facing the same direction. And they either both facing up or they both facing down. Okay, so that's for the even power in here. And let's look at that for the R power. So what happened with the R power? So what's the R power? If y equal to x, x to the 1 power, that's R, right? If you have a y equal to x to the 3 power, well, that's also an R number. So what's the R number graph look at that? Well, the R number graph gonna look like going to 2 different directions. Look at that. This is going down, this is going up. Similar to this one, this is going down, this is going up. So when you have an R power for the polynomial, they're gonna go to 2 different directions. This one both going to the same direction. They're both facing up or they're both facing down. Okay, and very similar if this one is coefficient. So like for example, if I have x equal to y equal to x, right? And this coefficient is 1. 1 is greater than 0. So when this is greater than 0, how does the graph look at that? It's gonna be an 1 and third section in here. So we're gonna have a 1, Q1. So this is called fourth section, right? A fourth quadrant. And then this is called a third quadrant in here. Okay, so you're gonna look like going to the fourth and the third quadrant when the coefficient is positive. When the coefficient is negative, like a negative x cubed, right? So this coefficient is negative. How does they look like? or you're gonna look like going to 2 and 4th quadrant. Okay, so look at it. So I have this 4th quadrant, 2nd, 3rd, 4th quadrant. Okay, this is X, this is Y. All right, so this is gonna be starting going to 2 and 4, going to 2 and 4. So that's the negative coefficient look at that. And it's going to the two different directions. Okay. So this page, I will just say, you might want to just go ahead and print out this page, print out this page at the beginning or do a little bit shortcut, for this page because it's very important in here. Okay. So let's look at this one right here. If I have this kind of 4 question, can you imagine how does this look like in here? Okay. All right. We can say this is a even power, right? So this even power and so even power, this is gonna be either facing up or facing down. And this one coefficient is positive, so this is gonna be look at something like that. Look at something like that. They're both facing up. All right. And how does this one look like? Well, this is R power, so you're gonna go to two different directions, right? So we're gonna go to two different directions, and then this coefficient is negative, which is less than 0. So this is gonna be going this one, and then somehow going this one right here, gonna be in 2nd and 4th quadrant in here. Okay, and how does this one look like? Well, this one gonna be similar to this one, but the coefficient because it's R power, right? So R power, they're gonna go into two different directions. Okay, and going to two different directions, and this is positive 1. So you're gonna be going through, probably somewhere in the middle right here. But eventually, you're gonna starting and ending in 1 and 3 quadrant. So that's how you look at that in here. Okay. This one is an even power, so you're gonna be facing down. You're gonna be facing down. Okay, and that's going to the same direction because of the even power, right? So this may be something like that. Okay, but they're eventually gonna be facing down. All right, because it's even power in here. Okay, so look at this one right here. If I have this one, can you match the graph, which one to which? As we analyzed earlier, right? So this is the even power, and so even power either both facing up or down. So this one must be facing this one right here, okay? Because this coefficient is positive, so that should be facing up. And the even power, so they're both facing the same direction. And we can find this one very quickly. This should be D for this one right here, right? Because this is the even power, and this is negative. So this will be this one right here without even using the calculator, okay? And let's see what else. How does this one look like in here? Match one of these graph. Well, this one must match this one in here, right? Because this is the even power, so going to the two different directions, one up, one down. And this coefficient is negative, so going to the 2 and 4th quadrant. So that is this one right here. Okay, so now we have a last one left. Okay, so what is the last one right here? This one must be this one right here. Must be C, must be matching A, because this is power, and this coefficient is positive. So you're going through 1 and 3, right? Okay, so this is, how we look at that in here. So now we have an answer in here. So that's how you look at that. This is the R power, okay, and the positive. So going through 1 and 3, okay. This is a negative coefficient. So going through 2 and 4 and going to the both directions. So that's R power, okay. This is negative coefficient, so facing down, and this is even power, so they're facing the same direction, okay? And this one is facing same direction because it's the even power, and facing up because the coefficient is positive. All right. So that's how you look at that in this one. Of course, you can always put this one in a calculator and graph them. Okay, but we also need to learn how we look at that without a calculator. Okay, so basically that is the fourth section is graphing in here. Any questions?
No, I'm good. I'm just following.
Okay. All right. Okay. So let's look at this one. Finding zeros. Okay. How do we find the zeros in here? Well, find the zeros is y equal to 0, the x value, right? So if we have this one, factor that for you in here. So what is a zero function? Zero function is you want to find a c value, which is this c is also the x value, right? And make a y equal to 0. So that's also finding the x-intercept for the graph, okay? So if we already have this one factored for you, so we have two zeros when x equal to 1 and when x equal to -2. So make each factor into 0. We have x equal to 1 and x equal to -2. So that's called zeros in here, okay? And how does this graph look like? Oh, we have a -2 in here, we have a 1 in here. So that's how you look like for this one, okay? All right, so we're gonna look at the even and call the multiplicity in here. So what is multiplicity? Multiplicity actually is the power, okay, the power for the what? For the this factor, okay? So k is called a multiplicity. If k is greater than or equal to 1, this is a factor of the polynomial function. Okay, so that is called the multiplicity in here. All right, so if k is a r power, if k is a r, what does r mean? That means the graph is gonna cross the x-axis. All right, so how does cross mean? Well, cross, that means the x changes from positive to negative in here, right? So this is called crossing in here. Look at that. This is called crossing in here. So this is called crossing. So if we have a y equal to okay, x squared minus 4. Okay, so all right, let's see. Let's look at a little bit more concrete one in here. So if you have a power k is r, this is cross. Cross, that means, if you enter from positive, look at this one right here, x equal to 2, right? Before, when x less than 2, y is positive in here, right? After 2, y become negative, okay? So y changes from positive to negative. This is called crossing. So the graph will cross the x-axis in here. The graph will cross the x-axis at x equal to 2. So that's called crossing. If this power is an even power, the graph is called tangent to the x-axis. So what is tangent? Tangent sometimes in some work is also called touching. The graph will just touch the x-axis. So how does graph touch the x-axis mean? Look at this one right here. This is parabola in here, right? So if I have this one right here, this graph, like I said, x equal to 2. This graph only touching the x-axis and then mouse back. So before this one right here, before when x less than 2, y is positive. After after passing the 2, y is still positive. So that means y did not change the sign, y stay in the positive one. So this is called tangent to the x-axis. Okay, sometimes it's also called just touch the x-axis briefly and then mouse back. All right, so you can tangent this one right here. So you can also tangent this one right here. Look at that. This is also tangent, right? My y stay negative in here when x equal to 2. My y stay negative. Between before x equal to 2, y is negative. After x equal to 2, y is also negative. So that's called a tangent in here. Okay. All right, so look at this one right here. How do we find a zero for this one? Well, if we want to do this one, we can do the factoring a little bit. We can do the grouping. We can group these two together and the last two together in here, right? So when I group these two together, and then I'm gonna minus this will be 9x minus 18, right? If I pull my negative 1 out, this will be 9x, and then this will become negative 18, and I can do a little bit factoring in here, right? So this common factor here will be x squared and then we have x minus 2 in here, right? And then minus this inside, I can pull 9 out, and then I have x minus 2 in here, okay? All right, so now we have x minus 2 in common. We can pull x minus 2 out, okay? And then we have x squared, therefore minus 9 in here. And 9 is 3 squared, right? 9 is 3 squared. So you have a x squared minus 3 squared. You can factor into x plus 3 times x minus 3. So that means we have a 3 zeros, okay? We have a 3 zeros in here. So each factor equal to 0. So x will be 2, x will be negative 3, x will be 3. So this is called 3 zeros, okay, for this one right here. All right, so that is finding the zeros in here by grouping, okay. All right, this one will be a little bit more complicated in here because we cannot factor this one by grouping, okay? This one we factor that for you in here, okay? We're gonna learn how to factor this one next class, all right? So this one you factor into x squared plus 11, x squared minus 3, right? If you make each one of them equal to 0, so how about x squared plus 11 equal to 0? Well, now you're gonna have x squared equal to negative 11, right? So this one you're gonna have an I solution. So that means we cannot see this point, this 2 point, because imaginary number you cannot see it on the graph, okay? But we can see the x, this should be x, not x squared in here. When you have an x squared equal to 3, right? And then you take a square root on both sides, okay? Or you can just take a square root in here. The book make a little bit mistake in here. This should be square root of x squared, and then you have an x equal to plus minus square root of 3, okay? All right, so when you have x squared equal to 3, you take the square root, make sure you have 2 answers, plus minus 3. And the square root of 3, if you go to using the calculator, that is about 1.732, okay? So this one you can show in the graph. This one you cannot see that from the graph. So basically, when you see this quartet, this is a quartet, right? And how does this one look like? Well, this one gonna look something like that. We have a negative 1.732, and then positive. I'm gonna just mark 1.7. Okay, so this is gonna be 2 zeros in here, and then you have a y-intercept. When x is 0, y-intercept is negative 33 in here. Okay, so this is gonna look at something like that. Oh, it should be negative 2. Look at something like that. This is how the quantity look like in here. Okay, so that means we have a 2 real zeros. These are the 2 real zeros in here. Okay, we have a 2 real zeros, and then 2 imaginary number, 2 imaginary zeros, which you cannot see. All right, so how many number of the zeros you can have in a polynomial? Okay, when you have a cubic y equal to x cubed plus 2x plus 1, right? So this is a cubic function. So my n here, the degree of the n, my n here is 3, okay? So n here is 3. That means polynomial has exactly n zeros, okay? This actually has, we're gonna say has a most n zeros. Okay, I'm gonna explain that to you later on. So what is a most? That means I can have 3 zeros or less. Okay, so now giving you a little bit overview for the fourth section. So our fourth section basically is introduce the polynomial. Okay, any questions? I'm gonna go ahead and introduce the second section in here because we're giving you a little bit more complete picture for this one in here. Okay. Oh, hold on. I had to get rid of the fourth section because it won't let me. the second section. Okay. All right, second section is continue the introduction for the graphing. All right, in this one right here. Okay, so how do we continue introduce this one right here? Look at this one right here. I just said earlier, if we have a polynomial with n degree, right? So for example, if I have a y equal to x minus 1 squared plus 2, right? How does this graph look like? Well, this graph, we're gonna have a vertex in the 1 and 2 in here. So this is 1. And actually, I'm gonna put a negative 1 right here. So this will be facing down, okay? So my vertex here will be 1 and 2. 1 and 2 in here. Okay, and then this is gonna be facing down. It's a quadratic. Okay. All right. So since I have a highest degree as 2, right? So my highest degree is 2. How many x-intercept I have in here? I have a 2x-intercept in here. So I have a 2x-intercept. Look at that. And most you can have a 2. You can have an n-intercept. So n is equal to 2. My n here is 2, right? It's 2 degree. So that means I can have a most 2 intercept in here. Okay, and how many turning point? I have m minus 1, so that means I have 1 turning point. So this is only 1 turning point. So what is a turning point? Why change it from increasing to decreasing? That is called a turning point in here. Okay, so why we say I have a most n intercept? Because if I have a y equal to x squared, this is still a quadratic, right? My n is still equal to 2. And how many intercept I have in here? Well, since this one is r power, and this one, look at this one right here. I only have a 1 x-intercept, right? Because this is vertex at 0 and 0. Okay, so what happened in here? I only have a 1 x-intercept. So 1 is less than 2. All right, so that means you can have a most. So that means you can have either 1 x-intercept or the most is n. N is 2. So the most x-intercept you can have here is n. Okay, so that's what I mean in here. So that means if you have a parabola, you cannot have a 3 x-intercept. You cannot pass the x-intercept 3 times in this case. So that means the n most. So n most, that means it can be less than or equal to. If you have n equal to 2, right? So n most x-intercept, that means I can have a less than or equal to 2. So that is called n most. N most is less than or equal to. Okay. All right, so how do we make a graph in here in this case? Well, I highlight a little bit, you know, the first one here is you look at the leading term, right? Leading term determine the behavior of the graph. So that is the most important one in here. And the second one, you're gonna find the x and y intercept, okay? So after you find the x and y intercept, you can mark the graph very well. The other one here is called a multiplicity. So what is the multiplicity in here? Multiplicity is trying to see the graph. We're gonna look at the graph. We're gonna be tangent or gonna be cross the either tangent or cross the x-intercept in here. Okay, so that's the multiplicity. Of course, you can always using a calculator to double check, right? But basically, if it's a polynomial, I can using this characteristic graph by hand without using a calculator. That's tell you this one right here. So if I want to graph this one right here, I pretty much can graph by hand without using the calculator, right? Because I know the leading term is 3. This is 2x cubed. That's the leading term. Coefficient is positive. Okay, so and then this is r power. So r power gonna go into 2 different directions, right? Going to 2 different directions. That's the r power mean. And this is called the ending and the ending behavior in here. And then this is gonna be positive, so this is gonna be going to quadrant 1 and 3 in here. So as long as I can factor this one, finding the x and y intercept, I can pretty much graph this one by hand, right? So how do you find the x-intercept, make y equal to 0? So we put a little bit grouping in here, right? So if I put this one out, this will become positive. If I put this negative outside in here, and this common factor is x squared for the first two terms. The second one, GCF, greatest common factor here is 4. So I have this one right here. So that means I have 3 zeros. Look at this one right here. We factor into, this is x squared minus 4, which is using x squared minus 2 squared, right? So you can factor into x plus 2, x minus 2 in here. So that means I have 3 zeros. I have 3 zeros in here, right? And what is the multiplicity in here? My multiplicity here, this is power of 1. This is also power of 1. This is also power of 1. So they are all R power. So what does R power mean? R power means they're going to be all crossing. Okay, so at each point, this is going to be crossing in here. All right, so how does, and then I also have a y-intercept. So what's my y-intercept? F of the 0, that's the y-intercept. That's 0, 0. So that's -4, right? So we look at this one right here. I'm going to be able to do this one by hand without using the calculator, right? We finding the zeros or the x-intercept. This will be -1/2. And then this will be -2. And then this will be +2 in here. And this is all power of 1. So each one of these will be all crossing in here. Okay? All right, so how does they look at that? I can sketch this one by hand without using the calculator. Okay? If I know all these characteristics. So if I have a -4 in here, right? And then this is -1/2. Okay, and then this will be -1, -2 in here, and then this will be 1 and 2 in here. So this is all crossing in here, all crossing. Okay, this will be all crossing in here. So how does crossing mean? Crossing, that means we're gonna go through the x-axis, change it from negative to positive or positive to negative, right? And how does this look like? This is going to the 2 different directions because it's a R power. And this is gonna starting and ending in 1 and 3 because the coefficient is positive. So that's how you look at that in here. Look at that. I can connect this one. This will be crossing. And then this one will be also crossing. And then go through the y-intercept. And then this is crossing. All right. So that's how the graph would look like in here. Look at it. I can do this one without a calculator. So this is called crossing in here. Each one of these is crossing. So I can graph this one. Of course, you can put it in a calculator, right? So how do you put this one in a calculator? Let me go ahead and show you the calculator very quick. Okay. All right. So let me copy this one down so I can put this one in a calculator. 2x cubed plus x squared minus ax minus 4. So I can put this one in a calculator. So let's see how the calculator works. Okay, so we're gonna go ahead and look at the calculator in here. How do you use the calculator to graph the polynomial, which is important, right? Because we do allow you to use the calculator, so that is a good advantage in here. And especially when you got to the polynomial, when you got to the rational function, it will be easy to use the calculator because the rational function is very hard to predict the behavior. Polynomial, on the other hand, is very easy to predict the behavior in here. Okay, so I go to y equal to, I'm gonna have to clear all of this. Okay. All right, so let's see. We have a 2x cubed. 2x cubed. So how do you put a cube in here? Using this one as a power button. So x to the 3 power, right? And then you have to move down. And then plus x squared, that's a built-in square right here. So that's right here. Minus ax. Okay, minus 4. And then you hit enter, and then you hit graph. Okay, So that's how you look at that in here. If you do not see the whole graph, you can go to zoom, right? You can go to zoom standard or zoom free, but I like to use zoom standard, just trying to see how you look at that in general, okay? So this is a crossing in here. This is crossing, okay? This is also crossing because Y changes from negative to positive, from negative, positive to negative, and then this is from negative to positive. So that is a 3x intercept in here. 1, 2, 3. Okay, so that is using this one right here. And then look at this one right here. If I have a quartet, okay, let's see what is our next right here. Since we have a calculator right here, I'm going to just tell you very quick for the next one. The quartet look at that. Okay, so I'll show you the other one since I don't want to switch back and forth very often. Okay, so the next one right here is x to the 4 power. Okay, and then minus 7x cubed. Okay, and then plus 12x squared. Okay, plus 4x. That's 16. All right, let's see how this one look at that. Well, we know this is gonna be facing to the same direction, right? Because this is look at this one right here. Okay, I'm gonna go ahead and now graph the first one, just to show you the second one right here. Okay, and if you don't see the bottom one right here, we can go to adjust the windows and let my Y minimum a little bit bigger so I can see the entire graph. Okay, so now you can see the entire graph in here, right? So look at this one right here. This is called crossing because Y changes from positive to negative. And we have this one right here. This point is called tangent. Look at it. This point at x equal to 2 is called tangent because I only touch the x-axis mouse back. So Y stay in the negative before x equal to 2 and after x equal to 2, right? And then this point is called crossing again because Y changes from negative to positive. So we have a crossing and then tangent and then crossing again in here. Okay, so that's how you look at the graph in this case. All right. Okay, so let's go back to finish this section in here for 4.2. So the graphing is pretty quick and easy. You can do that using the calculator, to double check it in here. Okay. All right, this is the one we talked that we just graphed that earlier in the calculator, right? Because when you factor this one right here, right? This is the power of the 2. So power of 2 is even power. Okay, so even power, it will be what? It will be tangent. Okay, so when we have x equal to -1, this will be crossing because this is the power of 1. Okay, when x equal to 2, this will be tangent. Okay, the reason is tangent because this is a even power. 2 is an even power. Okay, and then when x equal 4, you look at the 4, you look at the power here, now look at the 4. Okay, look at the power in here. So this is the power of 1. So we can say k equal to 1. I'm sorry, this is, all right. I'm gonna rewrite in another one right here. Okay, x equal to -1. So we're using the multiplicity k. K is a multiplicity, so k is equal to 1. 1 is a what? It's an odd number, so this one will be crossing. Okay, x equal to 2. Okay, and k is also equal to 2. K is a multiplicity, right? K is also equal to 2. 2 is an even power, even number. So this one will be tangent. Okay, x equal to 4. So how much is my k? K here is 1. This is power of 1. We don't have to write down 1 for a lot of things. Okay, so 1 is an R power again. Okay, so this point gonna be crossing in here. All right, so we can also find the y-intercept when x is 0. This will be 0. Everything will be 0 except negative 16, right? So if I graph this one by hand, okay, how do we graph this one by hand? We're going to say this is negative 16 in here, right? And we have a negative 1 right here, okay? And 2, this is 1, this is 2, okay? 3 and 4 right here. So what does that mean? That means x equal to negative 1, k is 1. So this point is crossing, right? X equal to 2, k is also equal to 2. So this point is a tangent point, okay, tangent point. And x equal to 4, this is also a crossing point. So I like to use a crossing point like this one and then mark this one right here. So I know which one is crossing, which one is tangent, right? So when I go to graph or sketch this one, so this is an even power, they're gonna be facing to the same direction. This is positive. So this is gonna be both facing up in here, both facing up. Okay, so how do I graph this one right here? I can sketch this one right here. I can sketch this one right. And then this is gonna be tangent. That means it's gonna bounce back and then crossing again. Okay, so that's how I can sketch this one right here. I can sketch this one. Of course, you can always using the calculator, but I can sketch this one, without using the calculator according to the characteristic we have for this one. Okay, so that's how the graph of the polynomial look like in here. Okay, and this will be the section 2. Okay, section 2. This is how the graph look like. This is a little bit prettier one in here. So we have this one is called crossing, right? And then this one is called tangent in here. And then this is crossing again in here. Okay. So you can use the calculator, but this is a good example for the using the knowledge we have. Okay. There's one called the intermediate value theorem. Okay. So what does the intermediate value theorem mean? That means, if I want to find a real zero between A and B, right? So intermediate theorems, that means, look at this one right here. Okay, so if I want to see if I have any zeros at this point or not, okay, so if I say this is equal to 2, I can say, I can look at when x equal to 1 and when x equal to 3, right? So how much is when x equal to 1? If my y is negative here, this is y is negative, right? And then after 3, so where's my 3? My 3 y here, y is positive. Okay, so that means when you have x equal to 1, y is negative. When x equal to 3, y is positive, right? How can you change it from negative to positive, by the way? Well, you must cross in the x-axis. You must pass the x-axis in here. Somewhere, maybe not in 2, maybe in here or in here. But between 1 and 3, you must pass the x-axis in order for y to change it from negative to positive. So that is called the intermediate theory in here, okay? So if you look at this one right here, when I have A equal to negative 4, B equal to negative 1, this is the x value, right? A 2x value between A and B, okay? So I'm gonna go to find plug A equal to negative 4 into the equation, and then plug A equal to negative 1 into the equation, right? And then look at this one, y here is negative, 16 is negative. And then when x equal to negative 1, y here is A, is positive. So you change it from negative to positive, right? So this is negative 4, this is negative 16, somewhere right here. And then this is when x equal to negative 1, this is A, somewhere right here, right? So that means between negative 4, this is negative, this is a little bit down here, okay? So when you have between negative, that means there's between negative 4 and negative 1, the graph must pass in the x-axis in here. So there's a 0, they call a zeros in here, a zero between negative 1 and negative 1, negative 4, and between negative 4 and negative 1 in here. Okay, so that's called the intermediate theorem in here. How about when between 1 and 3? Or if I plug x equal to 1 here, and this is less than 0. When I plug x equal to 3 and this is positive, right? So when x equal to 1 here, look at that, this is negative in here. And then when x equal to 3, this is 12. It's 12 somewhere right here, okay? So you have a negative, change it, y change it from negative to positive. So must be somehow in somewhere between negative between 1 and 3. This is passing the x-axis. So they call as a zeros in here. Okay. All right. So that's it for the whole section 2 in here. Okay. Any questions? Do you have any questions? If not, I'm gonna stop recording.